Hello everyone and welcome to my presentation on my market analysis of the German electricity market. I'm Daniel Flügel and today we are going to go over 7 pieces of content: the electricity market in Germany, basic mechanisms that guide it, then a supply and demand analysis, an elasticity analysis, an analysis of the firm behavior. Then we are going to look into the market structure and competition level. Finally, we are going to look at some government interventions and how they affect welfare. And finally, we will have a conclusion. Let's start with the electricity market in Germany. First of all, we want to define what exactly the market is that we are talking about. And the market boundaries are generally categorized in two ways. First, with the product scope and with the geographical scope. The product scope for our market is very clear. It's electricity, which is an homogeneous good, which means that electricity, no matter how it is generated, once it is in the grid, it is of the same quality. So customers don't have to worry about getting inferior electricity. It's actually an homogeneous good, just like you would have in a perfect competition. In the theoretical model. And the geographical scope is also very clearly defined. We are looking at Germany. So every electricity grid outside of Germany is not part of this analysis. Now, we want to understand basically how the German electricity market works, who are the key actors that we have to consider if we are talking about the German electricity market. And basically, we are starting with the electricity generators, and they are feeding the electricity that they generate into the electricity grid. And there are different types of grids. Some are the low voltage grids are operated by distribution system operators, and the high voltage grids are operated by transmission system operators. And the electricity that is fed into the grid can be traded on the wholesale market, which defines the price, and that finally the electricity is delivered by the grid to the final customer. It is interesting to know that electricity can be bought up to 6 months in advance and up to until 5 minutes before the electricity has to be supplied. But it always has to be consumed in the moment that it is supplied, because electricity cannot be stored in large quantities for a longer amount of time, at least not yet in an economical way. So now that we understand how who the core actors in the German electricity market are, let's look at the supply and demand analysis. For this, we will mainly focus on the generators and the final consumers, where final consumers can be private households, or it can be, for example, the industry, which accounts for about 42% of the electricity consumption in Germany. Now, if we look at the demand for electricity, at the consumption of electricity over 2 weeks, for every hour, we can see clear fluctuation that is very consistent. So we can see that the electricity is going down every night, which makes sense. The consumption is going down because everybody is sleeping. We can see that it peaks once in the morning between 9 a.m. and 1 p.m., which is where pretty much everybody in Germany is at work. And then it peaks, it reduces a little bit down during the afternoon, and it peaks again when everybody is at home, somewhere around 5 p.m. to 9 p.m. And then it goes down again. And this is a time horizon of 2 weeks, and we can see that in every week 2 days have significantly less demand, and that is obviously the weekend. And so we can see that the demand is very cyclical, And that does not only go for the weekly and hourly basis, but it also goes for a year. If we look at 3 years of electricity consumption, we can see that every January consistently electricity consumption is the highest, while it is lowest in the summer months, which makes sense because in Germany in the winter it is very cold, and therefore everybody is heating their houses, and everybody is also in the house, which means they are using more electricity, and it is also darker, which also leads to more lights. While in the summer, people are more often outside, not using electricity there. And Germany is a country that does not often use AC. So that is another reason why in the summer months, Germany has less demand for electricity. Now, if we look at the generation of electricity, it reflects this yearly fluctuation, but only if we look at the total. If we look at the separate types of generation, if we look at electricity generation by source, we can see that especially solar, so photovoltaic, and onshore wind electricity generation are highly unpredictable because they are dependent on the weather. And this unpredictability is accounted for with coal power plants and other conventional types of electricity generation that can um, that are more flexible and can uh, adjust for a lower or higher electricity output from renewable energies. So we can see that the demand is highly determined by the lifestyle, by the habits of people of German citizens, and the electricity generation is mainly determined by how much the photovoltaic and wind electricity generation can actually output, because especially the conventional electricity generators have to adjust for that, because the grid can always only take as much electricity as is consumed at that moment. So the supply has to always equal the demand, and if not, it is imported or exported from or to other countries. Now, if we look at the elasticity, firstly, we want to look at how the price changes and how demand changes when this price changes. And we can see, as we have seen in the last chapter, that the demand is very cyclical, but very constant in this cycle. And the price is not as stable. The price can sometimes move higher up and sometimes move lower, but it doesn't noticeably affect the electricity demand in this case. So if we look at how the um, price on the 5th of March here is very, very high, the demand did not significantly go down. So we can see that the demand is highly inelastic. But why does the price differ so widely? That can be explained by the supply of electricity, because if we look at the electricity generation by source again, we can see that every time the price goes up, it is in a situation where usually the wind energy is very low, which means that whenever photovoltaic and wind cannot produce the necessary amount of electricity, or can only produce a low amount of electricity, then it has to be accounted for by a higher output from coal plants, for example, and they have a higher marginal cost, and that is what drives the price up, because they have to sell electricity at a higher price. Now, if we look at firm behavior, this is highly dependent on this type of marginal cost. So if we look at renewable electricity, especially photovoltaic and wind, it has pretty much zero marginal cost. But the problem is it is weather dependent and therefore it is not always available. On the other hand, we have electricity from lignite and from coal, which are important conventional electricity generators in Germany because Germany does not use nuclear power generation anymore. And these two are much more flexible, but they have higher marginal cost. Lignite has a medium marginal cost, but coal has a very high marginal cost. And also both have higher CO2 emissions, but they can also have a high output and account for the electricity that the renewable energy cannot provide. What is important to know in this context is the merit order mechanism that decides which plant is producing at each time. And the merit order mechanism works in the way where at every time the plant that can produce at the lowest price, at the lowest marginal cost, will be the one that is actually supposed to supply the electricity. So whenever renewable electricity is available, renewable electricity will be supplying, but when it is not available, then coal and lignite and other types of electricity generation have to make up for the loss. Now, if we look at the market structure and competition level, we can see that there are 5 big competitors who are in the market for a long time already and have a big market share. But there is also now 38% of companies, 38% of electricity generation that is done by other companies that are not in those big 5 competitors. So if we look at the Herfindahl-Hirschman index, we can see that it is only about 1,000. We don't have the exact numbers of the market share of these 38%, but if we calculate the maximum, even if every single one of those had about 4% market share, which is like if we have 10 more companies with 4% market share, that's the highest we could get. Even then, it would only make up for about 160 more. So we can see that it is not a highly concentrated market. It is actually a competitive market. But there are still very large players who do concentrate a large market power in themselves, but it is not really an oligopoly because there are many electricity generators, therefore it is more a monopolistic competition. And if we look at the welfare implications and policy trade-offs, well, what is very important to think about if we are talking about electricity generation is CO2, because CO2 is a type of market failure, specifically a negative externality, because CO2 is produced by the people who generate electricity or by the users, but it is imposed on the entire society, even if someone might have a negative CO2 footprint. And therefore, it is the definition of a negative externality because this harm that they are imposing on a third party is not included in the price that the users are paying. And therefore, that is the definition of an externality, and CO2 emission is a perfect example for that. And now there are different ways for government intervention to deal with this. One is carbon pricing, which the EU is already doing, and Germany, as part of the EU, is obviously taking part in that. And by carbon pricing, they put a price on externalities, and it is enacted in the EU with tradable certificates. And thereby, there is a price on CO2 now, which counteracts the externality not being priced into the automatic market prices. From the other side, it is also possible to subsidize renewable energies that don't have these externalities. And that is what Germany did with the Renewable Energies Act. And that way they directly subsidize the renewable energy generators. And that way, even though demand is inelastic and therefore the quantity will not change, it is still a welfare for the suppliers because they have lower cost, or they get money back when they provide energy, and because they get these subsidies, they might be able to compete in situations where they otherwise would not have been able to compete. And that was financed by the government for a while. And since 2022, it is now funded by a fund that has been established for climate and transformation. And this climate and transformation fund is in part funded by carbon pricing, by carbon trading. So basically, we can even fund our subsidies with the carbon pricing and use these two interventions together to counteract the negative externalities in the electricity market. Now, if we look at the conclusion, what has this analysis brought forth? We have 5 key learnings. First of all, there is an inelastic electricity demand in the short run because customers cannot in the short run change their electricity consumption, and therefore they do not react strongly to price changes. Then there is the merit order price formation, so that the electricity plant that is supplying is always the one with the lowest price that can supply. And that way, renewables shape price dynamics because they have the lowest marginal cost, practically zero. And therefore, if renewables are available, the price is very low. And if they are not available, then the price is higher. And also, the market is dominated by a few large firms, but there are still enough little small firms that the market is actually competitive and not an oligopoly. And there are externalities in the electricity markets, but there are ways to counteract them with government intervention that have already been put into place. Thank you for your attention. This was my presentation. Here are my references that I used to create this analysis, and I wish you the best. Thank you very much.